That question is from semiconductor, and according to question, in common emitter amplifier circuit using NPN transistor, the phase difference between input and the output voltage will be. So as we know that the common emitter amplifier circuit are used to as a NOT gate. So that circuit are used to invert the signal. Means if input signal is like that, the output circuit will be phase opposite. Means the phase difference between the input and the output voltage will be 180 degree. Then the correct option will be A, 1. Okay, so phase difference will be 180.
Hello everyone, let's start the question. Question says that the temperature dependence of resistance of copper and undoped silicon in the temperature range 300 to 400 Kelvin is best described by. So here you have to find out the relation, and that is with temperature and resistance of copper and silicon. So here we see that the copper is metal and silicon is semiconductor. Okay, so first we talk about copper. So in copper, if we draw the graph, this is for copper. Okay, this is R and this is temperature. Okay, so the copper is metal. So in metal what happens, if the temperature increases, it increases it increases it increases the collision of free electrons. Okay, free electrons. Okay, so this increases the resistance. Okay, so this increases the resistance. Okay, but the temperature between 300 to 400 Kelvin, it increases linearly. Okay, so there will be a linear increase in resistance with increase in temperature. But if we talk about the semiconductor silicon, in this case, if we draw the graph, what happens in case of semiconductor, if the temperature is increased, then the density of the charge carrier also increases. Okay, also increases. So this decreases the resistance. So this decreases the resistance. Okay, so this between this temperature, the graph will be like this. Okay, decreasing exponentially. So if we check the options, the correct option is the linear increase for copper and exponential decrease for silicon. So this is the correct answer. Thank you.
Hello students, today we have a question. Identify the semiconductor device whose characteristics are given below in the orders. So we see the situation that this is a current and voltage varying curve, and this type of curve we have already have seen in the theory lectures. This is for simple diode. So we write for option A, we have simple diode. Now if we see the current and voltage curve of this, we can see this is a point in which the variation of voltage is breaking. So this is a point of break point of voltage, which is, we have studied, it is in Zener diode. So the option B curve represents the Zener diode. Now if we talk about option C, this is an illuminated and this is a dark part of the I and V curve. We very well know the fourth quadrant of negative current and positive voltage results the illuminated portion, and the positive current and the positive voltage, the first coordinate, represents the dark part of the curve. So this is for solar cell. So we mention it option C for solar cell. Now if we talk about option D, we can see that the resistance and intensity of a light. This is an intensity of a light, and this we have a resistance curve. So we can see this is a proportionality curve in which it is inverse proportional. So this is a light dependent resistance. So now we see that the option D matches with A, Zener diode B, solar cell C, and option D for light dependent resistance. So option D is the correct answer of this problem. Thank you.
In this question, a diode detector is used to detect an amplitude modulated wave of 60% modulation by using condenser capacity of 250 picofarad in a parallel with the load resistance 100 kilo ohm. Find the maximum modulated frequency which could be detected by it. Let's write the given data. So we get R equals to 100 kilo ohm. So we can write as a R equals to 100 into 10 to the power 3 ohm. C equals to 250 picofarad, which we can write as a 250 into 10 to the power minus 10 farad. And we have a mu, which is 60% of modulation. So we can write as a mu equals to 0.6. We know the formula Fc equals to 1 by 2 pi mu Rc. By putting values, we get 1 by 2 into 3.14 into 0.6 into 100 into 10 to the power 3 into 250 into 10 to the power minus 12. And we get final answer, which is Fc equals to 10.62 kilohertz. Hence the option A is correct. Thank you.
Well, hello students, now we're going to see this question. The question says that in a PN junction diode not connected to any circuit. Okay, so basically in a PN junction diode that is not connected to any circuit, what will happen? You can see over here what is a PN junction. Basically it is a P type semiconductor and a N type semiconductors, means basically joining. So basically if it is not connected in any circuit, okay, so what we can say that basically it is just a normal PN junction diode which is not connected anywhere. So let's suppose this is the P part, okay, and basically there is also the N part also. So this is the N part, let's suppose. Okay, so basically this is the PN junction diode. Okay, so if you see properly, then this diode must have a depletion region. Okay, depletion region is the region where basically the electrons from N type semiconductor, okay, electrons from N type, okay, join, means fill the holes on the holes on the P type. Okay, that means what, if this is N and this is P, okay, if the red one is P and the black one is N, okay, that means what will happen, there will be a depletion region forming due to the combination of holes that will be joining the from p side to n side, and the electrons which will be joining from n side to p side. Got it? So basically what will happen over here, there will be an electric field created, okay, from the n side to the p side. Why? Because electrons are going, so electric field will be created on this side, okay, electric field in depletion region. Depletion region. Why? Because basically this is happening, electrons from the n type are going to combine with the holes of the p type, okay. So basically what will happen over here, you can clearly see that basically our answer will be what, our answer will be an electric field is directed from the n type to the p type side, okay. So this is basically our answer. Why? Because the depletion region, in the depletion region, basically the electrons from the n side will go and combine to the holes of this p side, and due to that only this depletion region forms, okay. So basically our answer will be what, our answer will be option number C. Got it? Thank you.